and solve faulted power system networks for protection coordination of electrical equipment. Not only that, we just try to protect one equipment, we also need to make sure that all other equipment around that equipment that we are trying to protect are also protected. For example, I am using this laptop now. So if a fault occurs nearby to this laptop, then I will have to protect this laptop. Now, this laptop is not just the only equipment or the appliance that is connected to power system. It has also something around it. So we need to consider those as well, meaning we sometimes look at the area, or particularly we consider a zone. We call it zones of protection. So we create zones of protection and then we protect the zone. And while we do so, we try to keep the other zone around that zone active or live, so that that zone can still supply power to the equipment or the appliances that are connected to that zone. So that's how we do it. We also will study about the earthing system and the practices that we do in all possible applications, but to cover all of them is very difficult. It's not possible, because if you want to learn about the earthing systems and practices, it covers the whole world of earthing, that starts from the generating station, and we also have earthing at our households where we get our electricity connection from the supplier. It's there in the workshop, it's there in all the industries, it's there in all commercial installation, shopping malls, everywhere where there is electricity, there is an earthing system. So it's not possible to learn all of them, but we'll definitely learn something from that one. And then we'll also do the surge and over voltage protection in power systems. We get something called surge, voltage surge, and because of that we might have some situations where the voltage will exceed the rated voltage level, and because of that we might have a situation the equipments might get damaged, because all the equipment that we use that are supposed to operate at a certain voltage level, like this laptop is 230 volt, then we have a motor 440 volt or 400 volt, or even it can be 380 volt three-phase supply, it can be 3.3 kV, it can be 6.6 kV. So no matter what the voltage level is, who are waiting. So no matter what the voltage level is, they are designed to operate at that voltage level. So what we need to know now, how the surges are operating and how we can protect our power system and the equipment that are connected in power system. So that is going to be covered, and then there are some other things that will be in this chapter. Let me go to this content. So what we will do, I'll come back to the previous page after this. So we'll learn firstly the symmetrical components, where the theories related to fault analysis will be discussed, and this is the content that you see. It has a lot. I will give you an introduction to the symmetrical components, then something called Fortescue's theorem, then phase sequence that you have learned already in second year, third year time for sure, and then we'll have something for symmetrical components and so on, positive sequence, negative sequence, and zero sequence components. And before today, you always have dealt with or come across the current, voltage, and impedance or resistance. That is just like that. When we talk about current, it's current. When we talk about voltage, it's voltage. But from now on, it will be something positive sequence current, negative sequence current, zero sequence current. It will be positive sequence voltage, negative sequence voltage, zero sequence voltage, positive sequence impedance, negative sequence impedance, and zero sequence impedance, like that. So it's not going to be just current or voltage or impedance. It has now three different names, and they are different for some reason. So we'll discuss all those things, we'll learn, and then we'll come to something called the phase shift that happens when we have three-phase transformers. It's very important to understand that, and from there we will have something that we'll have to draw. We call them sequence diagrams, sequence networks. So we'll have to know about those sequence networks for different types of fault calculation, and that type of sequence networks changes from type to type. What type of component, electrical component is there? Is it a series resistance or series impedance? Is it a transmission line? Is it a synchronous motor or a synchronous generator? It's a transformer, three-phase transformer. And when we talk about three-phase transformer, there are different types of connections. In three-phase transformer, it can be a star delta, delta star, delta delta, star star, or even zigzag transformer, or even a transformer that has tertiary winding. Normally when we talk about transformers, it has two windings. We know that is primary winding and secondary winding, we call them. Sometimes we call them high voltage winding, low voltage winding, and so on. But also there are transformers that we use in our real power systems. They have three windings. So primary winding, secondary winding, and tertiary windings. So we'll need to learn on those things as well in this chapters, symmetrical components. So when we are done with that, we'll go for asymmetrical fault analysis, where we'll learn about single phase to ground fault, double line to ground fault, and double line fault. Also, we will include the three-phase fault that we have learned in power systems 1 as well, because the Fortescue's theorem that we see here is mainly used for asymmetrical fault analysis, which is difficult to analyze. With the application of this Fortescue's theorem, we will analyze them and make it easy for us to understand and do the calculation. And this Fortescue's theorem is so good that it also allows us to do the three-phase fault analysis as well. So that will be the second chapter, and then we'll come to the surge and over voltage protection chapter. We'll talk about something called insulation coordination, then the voltage time characteristic of insulations that we used in power systems equipment, and then basic impulse level of some of the equipments like transformer, the line conductors, the bus bars, and then we'll talk about the over voltages, which we classify as internal over voltage and external over voltages. And then we will also learn how we can protect the power system and the equipments that are connected to power system using over voltage protection equipment. So some of them will be covered in this chapter, and then we will come to the next chapter, which is called load flow studies in power network, meaning when we have a power network, how the load flows, meaning the power flows from generating stations through the transmission lines, and then it goes to the distribution stations. From the distribution stations, it goes to the consumer's premises, where the actual power consumption takes place. So that part will be covered here with some network model formulation, and then we'll learn how to make the formation of admittance bus matrix, because that bus matrix is going to help us with the calculation of power flow. And then we'll learn on some methods that we normally use for load flow studies, but for the module, this module, as it's 8 credit module, so I had to limit something here, almost in each and every chapter. Like I mentioned, in earthing system and earthing practices, it's difficult to cover everything in terms of earthing and earthing practices. For protection, it's also difficult to cover everything, because each of them actually become a 16 credit module. But if you combine them, all of them in one module, and it still cannot be 8 credit. So I have to limit it to some extent. The one that we are going to learn is the Gauss-Seidel method. Apart from that, there are other methods that we will do in the assignment, like Newton-Raphson method, fast decoupled method, and so on. So that part, that chapter, I kept it small actually, and tried to make it easy for you. Then the next chapter will do power system stability. Actually, it's a module at UKZN power system stability, but we don't or cannot offer these days because of the number of academic staffs that we have. It's very unfortunate though. In our building, we have electrical, electronic, and computer engineering, three different programs. And in electrical engineering, we are the highest. If you combine electronic and computer engineering, we still bigger than them, but we on the other side have the least number of academic staffs, so we cannot offer that module. But this module has this section or a chapter, power system stability, so I make sure that we learn the basics and the most important aspects of power system stability, where we learn the stability concept that comes from control systems in the first place, and then we apply them in our machines considering something called swing equation, how the machines swing, generator swing, and there are different criteria. One of them is called equal area criteria. We learn that theory and then we'll apply them in tutorial. And then the next chapter is about the earthing. Why do we need earthing? How do we do that? We also need to know something about the physical characteristics of earth, because when we earthing means we connecting our appliances to earth physically using a conducting material. It can be a cable in which there is a conductor, metal conductor inside, and we connect it to the ground. And what type of earthing electrodes that we use in our applications, because it's different from for different applications. Like for example, if you are trying to earth a generator neutral at the generating station, it has to be different from the one that we use at our households when we trying to have earthing systems. So those things will be learned in that chapter, earthing and earthing practices. But again, cannot be covered. I cannot cover everything here in this chapter, because it will become even a 50 credits module, something like that really. And then power system protections, I try to keep it very simple, because if you say power system protection, that is written in the green book. But again, if you want to cover everything here in power system protection, maybe it will become a module of 200 credits. So that's not possible to manage here. So I try to keep it simple. We learn the basics of protection, then we learn how we use fuses and how we use relays. And when we talk about relays, there are so many different types of relays, but we cannot learn all of them in this module. But we make sure that we learn at least the one that we always use in most of the applications, like overcurrent relays. So we learn about that one. So all these contents will be covered from the very beginning. Possibly I'll start tomorrow if I can complete the course outline today. If I cannot, then I'll go continue the course outline next time. But let me go to the top. That's me, and this is my email address. All of you should know that. If you don't know, you must take note of that. And email is the most important means of communication these days, because we cannot see each other. We are not on campus because of this situation. So make sure that you know the email and you communicate to me via email whenever you need anything in this module, power systems 2, or anything else. So that's me. And then I'm coming to the course outcomes. So when we will complete this module, we will be able to carry the fault current calculation for symmetrical as well as asymmetrical. But again, we will not be able to cover everything in terms of asymmetrical fault calculation, because inside single line to ground fault, there are types of faults that are very difficult to cover. If you write a book on only on asymmetrical fault analysis, it will be 600 pages or so. So we cannot cover everything again here. So, but we'll make sure that we learn the important one. Then we will have to know how we do the power system protection. Then we'll be able to carry out the overcurrent protection system in our power system, and then we'll need to know how we will be able to do the load flow studies via some tutorials and assignment as well. And then we'll do the insulation coordination over voltages. It actually taken, all these things are taken from the that content that you see, that you saw on the table. So large power system networks analysis for load flow studies, that will be another outcome. So the questions in tests and assignments will be based on these 6 bullet points that you see here, that are based on these 6 different chapters that you see here. So that will be covered. And then I'm coming to the other important thing that is always related to you. I guess that you have opened that course outline already and found it, but just today I changed it a little. Initially the quiz was not there. Now what happened, I'm not happy with this though. They made it mandatory to have 5 quizzes for this module, so that will have 10% marks, and then there is 2 tests, test 1 and test 2, 20% from each of them. It will give us 40%, and then there will be 2 assignments, 25% each, will give us 50%. So that gives us 100% for the class mark, and the final mark will be equal to class mark. But just for us to make note, we don't know how it will unfold this semester. It might happen that we might end up having an examination session, like true examination, like what we have been doing since the beginning when we started going to school. Sit down and write. That might come back. So we need to just keep that in our mind, that it might come back, it might not come back as well, we don't know. So if it comes back, we will have to write an exam, sit down. But if it comes back, you will know it before I know it, because last week I came to know from you that there is going to be no lecture, because I'm busy with other things. I did not notice that there was a notice. So you will know about it, but those things will happen. Now coming to this quizzes, tests and assignment. The assignments are already there. I gave you the assignment, but I will talk about those assignments a little more maybe tomorrow, because I see only 6 minutes there. But let me talk about the quizzes and tests today at least. Then I will talk about the assignment report in details, because that's going to give you 50% mark. It's very high. So 5 quizzes, how it will be run. There will be no dates announced before the quizzes are going to happen. So what will happen, let's say maybe tomorrow there is a quiz, I don't know. I will decide instantly, and you will have to do that after the lecture on that particular day, but not immediately after the lecture. So maybe let's say if I do a lecture tomorrow, then after the lecture I will let you know that there will be a quiz at 5 o'clock. From 5 o'clock to 5:15 for 15 minutes. It will be very short. You can see 2% mark. So maybe I'll give you 2 questions to answer in 15 minutes time, and that is done and dusted. There will be no catch up, no nothing about that. We cannot have a makeup or catch up on that, and though no dates will be announced prior to that, the dates will be announced on that particular day, like I mentioned. Maybe around 12 o'clock tomorrow, after finishing the lecture, I'll tell you that at 5 o'clock there will be a quiz. It will be opening online from 5 o'clock. It will remain open until 5:15. After that, it's closed. Nothing can be done. So we'll have 5 of them. Is that okay with you? Is there any problem with that quiz? Please let me know. Okay, that's fine. Thank you very much. So that's how we'll run those quizzes, and for tests, I have announced the dates down there. I will also show you the Moodle website tomorrow. The test dates are here. You can see 8th of April, 3rd of June, and the timings there, 10. I normally give more and more time than what you need, and the content will be online. You will write it from there, and you will write using a manuscript book where you will use a pen and not pencil, and when you are done you will take a photo to convert it to PDF and submit it via the Learn website. We're not calling it Moodle anymore. I don't know, we are so clever, we know how to call a Moodle Learn sometime, and then next time we will call it Moodle again. Yeah, so you will submit via that learning website, and don't email me. The reason is that when it is emailed, there is always a chance that I might miss that email, because daily I actually handle hundreds of emails from different sites, because I'm at the school, or whole school, like chemical, civil, mechanical, PMB, all people are communicating to me, all the professors, lecturers, senior lecturer, their super students, then the college office, research office, everyone. So I might miss it, and if I miss it, what will happen? Nothing will happen to me. You might just end up failing, and then when we discover it, it's too late, and then it will create a lot of pressure on both of us, you and me. So that's why I'm trying to say that I'll give you enough time to submit it via learning website, so that we don't have to go through that email option. So that's how it will go, and we'll talk more on the assignment tomorrow, how you do it, because some of you might have already been trying to attend those assignment statements and trying to simulate something. You might have some questions, so we can take those questions tomorrow, and it will be clear to you how you do them and what are the things that you must show, because I always expect something very specific in those assignments, because it's very important to me. It's unfortunate again that we cannot do the practical this year, and I'm very unhappy about that though, but I cannot do anything. The reason is that the practical that we do normally in Power System 2 is, in my opinion, is the best practical in all electrical engineering. But it's unfortunate. But last year when this corona thing happened, we started having this lockdown. I spent a lot of time to have some assignments that will also give us some opportunity to learn something that is serious in electrical engineering. So that's how why you see those two assignments. One is on load flow studies, the other one is on power systems protection. But I'll give you more insight, and you also should prepare your questions for tomorrow, because I will discuss the assignment things in details, taking questions from you so that you understand it clearly and do well. Not only that, the other reason is that this assignment is related to EXA ELO 4, that is a mandatory, meaning it is considered as sub minimum for this module. So if you fail this assignment, you fail the module. So we give a lot of effort to this assignment. So that's why I'm going to discuss that tomorrow in details, and make sure that you have your questions ready for tomorrow. Can I keep it up to this for today? What do you say? Tomorrow we'll discuss everything in details, especially the assignment, which is a big task. I will also discuss about the tests a little more, because it's online, and also the quizzes I will give you a little more. Today I just gave you the superficial aspects of quizzes, that 5 quizzes will be there, 2% from each quiz. Dates will not be announced. It will be announced only on the day, few hours before it takes place. But we will discuss everything in details tomorrow, because tomorrow we have a double lecture, so we'll get more time.